All right, so today we're going to pick up where we left off last time. We were talking about radiation. We started talking about radiation view factors. And we went through several examples here, or methods, I guess, for estimating radiation view factors. We started by saying, well, first of all, a radiation view factor is defined as the amount of radiation that hits surface J that's emitted from surface I. So not all of radiation coming from I is going to ultimately hit the target surface J. Some of it will, and that fraction is defined as our view factor. So we can evaluate the view factor either first by inspection, that's what we went through last time. So inspection, we can use libraries for this. There's an integral that we'll talk about today. There are rules that you can use, and there's something called the cross and uncrossed strings method. And then lastly, there's the Monte Carlo methods that are really flexible. We will talk about 1 or 2 through 5 today. We talked about 1 last time. We will not talk about 6 today, but I do hope to get to that in a later lecture. Let's see. That's where we left off. We did decide that by inspection you can do some interesting things, but it is maybe a little easy to talk yourself into inspecting things that aren't there, so be careful about that. In this example, we said, surface 1, our inner cylinder is can't see itself, and it can only see surface 2. So any radiation that's emitted from 1 is going to hit surface 2. That's by inspection, we know that's true. So we can use that to our advantage. And you'll see as we go through this process how you might use little pieces here and there to ultimately construct everything you need to evaluate other view factors. Okay, so now the second thing we said we could use was libraries. There are lots of people who have tabulated these view factor calculations for you. Not every situation is covered in a library, but there's a pretty good list in a couple places. So one would be ease. So first let's look at ease. If you go to the function information, heat transfer fluid flow, there should be a view factors library. Let's see, where's the view factors? Radiation view factors right here. So radiation view factors, you can go through and first we'll pick what's our situation. Do we have a 2-dimensional situation or do you have a 3-dimensional? So 2-dimensional is going to be, you assume infinitely in and out of the page. And then the geometries as shown. 3-dimensional would be you actually have some 3-dimensional surfaces that you're trying to deal with. You can flip through these and see all the different possibilities. There's spheres, there's cylinders to spheres, there's just anything you can imagine. It's a little bit easier to actually click the index here. If you click index, it'll list for you all the possible view factors you could choose from. So you can see there's a ton of them, right? So we could look first, here's all the 2-dimensional view factors that you might want to use. Plate to plate, some at an angle. Let's say you have a boiler, you see the tubes over a plate like that. You could do that. So different situations you might want to use these different view factors. There are also 3-dimensional, so we can go back here and look at the 3-dimensional view factors. So again, you can see there's a lot of different view factors you can choose from. So you might find that your situation is covered here, you might not. If your situation's not covered here, you're probably going to need to do something like Monte Carlo ray tracing. Okay, so these are all here, and the way you use them is you go to us. Let's say we have, I think this was an example from last semester in 364. So you come in here and you look at the geometry, how it's defined, and then you basically just call this view factor function here. This one is F3D57. So we're going to give it our geometry, give it our angles, and it'll give us back. In this example, it gives us back, okay, 26% of our radiation is going from surface 1 to surface 2. So the thing to keep in mind here is it's always, in these, it's always surface 1 to surface 2. Going from 1 to 2 in all of these. So you might see this situation and you might want to compute 2 to 1. Well, this is not your view factor, right? This is going to give you the wrong answer if you try to do it backwards. Okay, there's also, let's see, where was that? Oh yeah, so this website is one of probably several you could find, but this is a pretty exhaustive one. If I have this up. Yeah. So this website has a lot of the same view factors if you wanted to look at them. You have these different groupings. So here we have differential area to differential area. If you have like a differential element, so you pick two things, it'll show you, here's my differential element, here's some geometry that goes with it, and then here's the actual view factor calculation that you could do. Right, so you can go through, and it's a really exhaustive list here. Cylinder to cylinder, so you might have whatever you want in here. There's kind of a lot of different options. So these are resources that exist for libraries. A lot of the time what you're going to want to do is, it's a little bit cumbersome to find the library. You have to go look through the catalog and all that. So usually the way to deal with these problems is you first pin down anything you can by inspection. Then you're going to use any rules that you can. We'll talk about the rules in a minute. Use any rules that you can to identify other view factors. Anything that's left over, that's where you'd go look for libraries to fill in the gaps. All right, so those are libraries. Anything to talk about there. So, okay, the third thing we'll talk about here just really briefly is the integral method. The integral method is, it's actually not something we're going to do in this course. It's there, you can do it if you want. If you are really interested, it's actually something that you ever teach 766 again, which is radiation, advanced radiation. It's covered there, but it's actually not, we'll not do it here, but I'll give you what it is just so you know what to look for there. So the idea is that, let's say we have these two surfaces. We have this little differential element on this surface I here. It has a normal associated with that element. You have another element up here with its own normal, and then there's a vector that connects these two things, right? This vector connects these two differential elements. So the angles between the vector and the normal to the differential element go into this formula. Okay, so the idea is that if we say AI times Fij, that's my area of surface I, and then the view factor from I to j, right, that is going to be equal to this following integral. So it is the integral, it's a double integral. So the integral is going to be over AI, and the outer integral is going to be over aj. So we have these integrals, and then we have in the numerator cosine of theta I times cosine of theta j, and that's divided by pi r squared, and then it's the differential dAi dAj. Okay, that actually is also equal to the product AJ FJ I. All right, so if you just think about what's happening here, right? We're taking some reduction in how much one element can see. So how much element I can see of j, right? That is cosine of I. And then we're taking a reduction based on the same view from I to j, and that's cosine theta j. Right, so those two cosines together sort of reduce how much each of the differential elements can see each other based on their angles between the connecting vector. Right, divide that by the total plane that or the circle that they're living on, and that gives you the view factor. Right, so the way to actually use this would be probably in a numerical setting. So you would discretize your surfaces into a bunch of little nodes, compute for each little node what the product is, and then add, do the integral over those, and add it all up, and that gives you the total view factor. So you can do that. It's a method for evaluating the view factors. You can go through that procedure. But like I said, you just need to know that it's there. It's a possibility if you really need to use it, but we won't talk about it further.